Okay, so we're gonna go over domain and range in today's lesson. First, let's go over the definition of domain, which could be found at the top of your interactive notebook. So domain are all the possible input values you can use in the function. So all the possible x values that you have in a function. If you take a look at this graph, that would mean the values from here, where the x value that this graph starts at, and the x value that this graph ends in. So that might be a little clearer when we do some examples, but for now, just associate domain with all your x values. In the same way, range would be all our possible outputs, so all our possible y values. So if we look at this graph, you can see that the range is the y value that it starts at and the y value that it ends on. Again, this might make more sense when we do some examples, but just associate range with all your possible y values. Before we look at the Regents examples, let's talk about interval notations, because those appear in the Regents examples constantly. So first, parentheses. When you're using interval notation and a parentheses is written, that means that the numbers with those parentheses are not included. So, for example, if you have parentheses 2, 5, that means that 2 is not included and 5 is not included. This might be a little confusing because this also looks like a coordinate pair, but in this case, this is not x and y. That's not what this is saying. This is saying that the interval goes from the number 2 all the way up to number 5. In the graph, you would have an open circle at 2 and an open circle at 5 because those are not included. In the same way, let's talk about brackets. When you are using interval notation and you are using brackets, those values are included. So, for example, if you have a bracket 2, 5, close bracket, that means 2 and 5 are included in this case. And if you were to graph this, there will be a closed circle at 2 and a closed circle at 5. I'm just going to pause for a second to ensure that you're also filling in your interactive notebooks in the blanks. So if you like, you can pause the video here to write these notes down. And then if you didn't get a chance to write your notes for parentheses, I'll just scroll up and you can pause here to write your notes for parentheses. Okay, so that was interval notation. Another notation is inequality notation. And these symbols should be familiar to you because we've used inequalities before, but let's just remind ourselves what they mean. This means less than. This means greater than. This means less than or equal to. Since we have the little line under the symbol, that's where the equal to comes from. And this one means greater than or equal to. Again, the little line in the bottom is a hint that we'll have to include equal to. So go ahead and fill those in your notes. And then let's talk about what these look like in the number line. When you use less than or greater than, you have an open circle. because those values wouldn't be included. When you use less than or equal to or greater than or equal to, you have a closed circle, and those values would be included. So, let's look at some examples to make some sense out of those symbols. If you have this inequality notation, what this means is all numbers, so this x is greater than 3 means all numbers greater than 3. When you have this inequality notation, x is less than or equal to 6, it means all numbers less than or equal to 6. And then this one might be a little difficult to read using the inequality symbols, but this means all numbers between 1 and 4, including 1 and 4. And a little hint to learn that is the fact that the x is in between 1 and 4. So that the structure of the notation tells us since the x is between 1 and 4, is all the numbers between 1 and 4. Go ahead and fill those in your interactive notebooks. And then let's do some sample regions questions. Okay, so this is the first one that is in your interactive notebooks. The question reads, the graph of f of x is shown below. The domain of this function is. So let's annotate this question. The keyword in this problem is domain. And we know that domain has to do with x values. So we're going to ignore our y-axis because this is talking about domain. So we're going to only concentrate on the x-axis. And first, we're going to look at where this graph, so that means just this, not the entire grid, but only the line where this graph starts. Oh. Where this graph starts. So this graph starts at x value 0. This graph ends at x value 12. So, using that information, we know that this function domain is all the values between 0 and 12. But now the question is, do we include 0 and do we include 12? Since the dot at 0 is open, is an open circle, this is not including 0. And since the dot at 12 is closed, this is including 12. So let's look at our options since this was a multiple choice. We know that this can't be the case because we know that this would mean that we're starting at 15 and at 45, and we're ending at 45, which is not the case. So this, for the same reason, this one wouldn't be the case. So now if we look between options 1 and 3, both are saying that the line starts at 0 and ends at 12. But option 1 is using brackets for both, which means it's including both 0 and 12. So that wouldn't be it because our graph, since the circle at 0 is open, does not include 0. So that's why option 1 is not it. Then if we look at option 3, the inequality symbols it's using, since the inequality that goes with 0 doesn't have a line under it, that tells us that it's not including 0. So number 3 is the correct option. Go ahead and rewind the video if you need to, pause it, annotate your question, rewatch this portion of the video before we go on to question number 2. So the second question is question number 2. And this question doesn't give you a graph, but it does give you a function. So the question reads, if f of x equals x squared plus 2, which interval describes the range of this function? So let's annotate this question, and the keyword here was range. And we know that range means our y values. Okay, so since this doesn't give us a graph, we're going to use our graphing calculator to see what this graph looks like, because it does give us the function. Let me see if I have my graphing calculator here. I do. So we go into our graphing calculator and we go to y equals, and we type in x squared plus 2. So x squared plus 2. And then we can simply go into graph. Now it might be a little hard to look at here. So I think, oh, there we go. All right, so since we're talking about range, we see that the lowest y value is 2. And then we see that thing is going all the way infinity. It's not stopping anywhere. So the lowest y value is 2, and it goes all the way up to infinity. So let's keep that thinking when we go here. So let me just summarize what we found in the graph. The lowest y value is 2, and it goes to infinity. It goes up to infinity. So let's look at our options. Number 1 wouldn't be it, because it's saying that it's going from negative infinity to positive infinity. And we know that we have a limit on one side, which is 2. 0 doesn't play a role in our limits, so it wouldn't be option 2. So now we're debating between option 3 and option 4. Option 4 is telling us that we're going all the way down to negative infinity. And that's not what our graph shows. So let's confirm our answer of choice 3. This is saying we're starting at 2. Our lowest value is 2, and that's correct. And it goes all the way up to infinity. So go ahead and pause the video, look at your calculator, and confirm your answers.